Namaste to everyone. So yesterday we had actually a chance to celebrate Acharya P.C. Ray's birth centenary, and at Isa Trivandrum. And in the morning we had a function where we told a lot of school children, about 150 of them, about the contributions of Acharya P.C. Ray, and then they had some quiz and everything. So it was a very nice function, and it was very good to see that students were very actively participating in the function. So in fact, when I rose to spoke, I asked many questions to the students, and students quite actively participated in answering the questions and so on and so forth. So it was very nice feeling. In the afternoon, I had a chance to talk to the ISA students and faculty about how science and technology has transformed India after 1947 till today. And I had a chance to recall a few selected examples of how science has continued to play a major role in our society. So, in that sense, if you actually look back upon that how we have traveled since 1947, so the first thing that I always start saying there in talks such as the yesterday afternoon is that in the year 1700 or in the year 1800, India's contribution to world GDP was very high, of the order of about 20-25%. And in 1947, when the colonial powers left, it had reduced to 2%. And yesterday actually showed figures of the economic contribution of India then and now. I mean, in the year 1700, 1800, and 1947, and now. And unfortunately, what has happened is that uh, because of the colonial exploitation of our resources, we actually became a very poor country in 1947. But even worse thing that happened during the colonial period was the exploitation of our mind and suppression of we as a population, and we were subjugated to kind of feeling that we are in some sense inferior to people who are residing in the other countries, to the extent that we don't have the capability to think rationally and things like that, And that subjugation of our mind has played on Indian side for a very long time. And one of the things that Vigyan Bharati is trying to do today is actually trying to give confidence to the younger generation that there is no such thing as we being inferior to anyone, and give confidence that in the coming time we are no less than anyone else in our intellectual capability, and we are no less than anyone in our rational thinking or our scientific attitude and so on and so forth. And in fact, we have a kind of backing of a very strong cultural heritage in our country. And when I speak of this, I go on giving multiple examples of how science and technology was so well developed in India. So they're the kind of things that we tell school students. I don't need to tell this particular audience how the science and technology was so well developed in our several centuries, even before the colonial powers came in. I don't have to say, especially in Kerala. Uh, but to yesterday's audience, in the ISA Trivandrum audience, I chose two specific examples from this part of the country, how science actually was being practiced a few centuries ago. And one example I gave was of the Dutch governor, Van Reed. Some of you would have heard of Van Reed. And Van Reed, along with a doctor called Dr. Ichi Achuthan, together made a collection of plant this thing and medicinal properties and all. And this was before Carl Linnaeus actually classified all the plants, about 30 years before that. And today, the species name that are given, for example, Homo sapiens, the name that is given, comes from the Linnaeus classification of the system. But much before Linnaeus classified, Van Reed and E.T. Achuthan together had actually made a catalogue of all the plants, what we call as, is very famously now called as Hortus mulbaricus. And that particular catalogue is actually very famous now in the world literature, and we're going to start talking much more about it in the coming time. The second example that of course give is the school of Madhava, who in the pre-Newtonian time had advanced mathematics so much, the Madhava school which was existing here in this particular region, and in the pre-Newtonian time had made several strides in understanding of, let us say, sign theory or some of the mathematical functions and so on and so forth, and also had calculated motions of planets and this and that. Based upon all this cultural heritage, people like P.C. Ray actually built up upon that and tried to resist the British thinking that you cannot suppress our mind or thinking, saying that you are not a rational population. And P.C. Ray was one of the foremost of those thinkers in that period, about 100 years ago. And he started, with that particular feeling, also a company called Bengal Chemicals and Pharmaceuticals to make India self-reliant. And today's theme, of course, is self-reliance. So P.C. Ray was one of the first persons who recognized about 100 years ago about self-reliance, and he started that with very Swadeshi fervor, with very nationalistic spirit, this particular company. And of course, many others followed the suit. Around the time P.C. Ray did this, the Tatas also had started. Uh, uh, Tata's also had started three principal industries in India in the turn of the century that tend to make India self-reliant. There are three industries that he started. One was Tata Steel, the other was Tata Power, and the last, what Jamshid Tata actually dreamed of, and he was given the idea by none other than Swami Vivekananda to start an Institute of Science, what we today call as the Indian Institute of Science, Bangalore. So there are the three things that Tata's also had started. Around the same time, Abdul Khwaja Hamid also started a pharmaceutical company in Mumbai, and that eventually came to be known as Cipla. So these are the kind of things that people actually started making India self-reliant. In the post-independent India, of course, as we started, multiple things that happened to make India self-reliant, and there are many examples we can go on recounting. For example, in the 1970s, when there was a balance of payment crisis, right? A balance of payment crisis, most people have heard. 1990 was one of the severest of the balance of payment crisis that came about. But 1970s there was a balance of payment crisis, and India could not import much of the equipment that was needed for multiple things, including the agriculture. And that's the time when India actually made its own agricultural equipment. Things like the tractors that was made, the Swadeshi tractor that was made in Ludhiana in the Central Mechanical Engineering Research Institute, and it was spun off as a company. So multiple different attempts were made to make India self-reliant. And what we have seen during the COVID period in recent times is that there has been a very strong focus on making India really a self-reliant nation. I think that's a very good thing, that what we are trying to do. I would just like to highlight three examples of recent times that have caught public imagination. One, that of Chandrayaan, that all of us are proud of, that India was successfully able to land rocket on the moon. This is one of the recent examples. One was the COVID period, in which India became self-reliant on almost everything. Before COVID came, we were not able to make much of the things here, including small things like nasal swabs, PPEs, and very small, apparently small things. But we are not able to manufacture on our own. We are importing all of that. But COVID period was a real awakening for all of us, and so many things actually happened in the country. We can just go on recounting. I've been giving seminars at multiple places that how India fought the COVID battle. It's just an amazing story. How India became self-reliant. But to take a stock of the situation, and if you want to make India really a self-reliant nation, right? Because our society has already stated its aspiration that we want to be Vikasit Bharat in 2047. That's the aspiration of our people. Right? Our people want India to be a developed nation in 2047. And for that, if we have to do that, we will have to make sure that the technologies of the future that are generated are actually generated by India. Right? In the coming times, all the technologies that are being made India should be a competitive nation that, along with the most advanced nations, we also start making those technologies here. The conversion of science into technology also happens in India in future. It's not possible that every technology will be made in India because there is competition around the world. But if we make an effort in that particular direction, and if we are able to push for science and technology as the principal driver of our society's growth, and if actually we start working in that spirit, that we'll start making things here, the future technologies would be made here. So then we do indeed have a great hope that India would be a Vikasit Bharat by 2047. And what are the kind of technology that we need for tomorrow? It's not a rocket science to think about it. You don't need great intellectuals to tell us what kind of technologies we need for tomorrow. We need things for sustenance of our nation. We need things sustenance of the entire globe, entire world. Our philosophy has always told us that we take the entire world along with us. Right? I mean, India's philosophy has always been Vasudhaiva Kutumbakam, right? So we take the entire world with us, and we need to develop whatever solutions for tomorrow right here. And if we are able to do that, I think we'll be able to do. And there are 17 Sustainable Development Goals that the United Nations has listed out, and many of them are quite relevant to India. And if we start working on those, I think we will do well. I will stop by quoting the last example that I wanted to give. So Sustainable Development Goal 1 is ending poverty in all its forms. It is SDG 1. And what do you think India has done in the last 10 or 12 years? If you look at the statistics, what India has done in the last 10 or 12 years, and it is not India generated statistics. This statistics has been generated by UNDP, the United Nations Development Program. They have actually generated particular statistics. And India has lifted close to 400 million people out of what they call as multi-dimensional poverty. Right? 400 million people. That's the UNDP statistics that India has been able to do that. And we have been able to do that only because we have been able to implement S&T based solutions, science, technology and innovation based solutions, along with the political power, along with the political will to implement them, and along with the entire government machinery, along with all the industries, and along with the willingness of society to accept it. The solutions prepared by science, technology and innovation, all together we have played a role in pulling about 400 million people, that's more than the population of US, out of multidimensional poverty. And that I think we should be very proud of, that we have done that. But the work has not stopped here, and the work should march with equal spirit, as much spirit now, towards what we call as Vikasit Bharat, to make India self-reliant in 2047. So let us all commit ourselves to that goal, and I wish all of you all the very best. Thank you.
And reaching out to even not the cities, but to tier and three-tier cities, which is very, very important. Then the other aspect which we need to actually promote is translational and product development for commercialization, which is very, very important for us to develop that ecosystem, which basically engages public and private sectors, and it needs to encourage public-private partnerships model and co-develop that together. This is required especially for India because there is a need for being not over-dependent on the government itself for doing all of these things, and that has been also there in the policies of the government. Then while we are doing the translation and product development, we will not be sustaining our strength until unless we have a very good balance of basic and translational research. Many a time overemphasis on the translational research is there, but until unless the basic research is also strengthened, you will never be able to come up with robust pipelines for new knowledge, which helps us in making newer and newer technologies. So these are the four paradigms we need to actually work on, and that was the suggestion at that time by that committee. Now, how is our country developing biotechnology wise? You can see already these numbers are already known to you. In 2024, with an estimate of 18% increase itself, we have around 109 billion dollars US dollar worth of biotechnology industries in the country valued. And if you take that 18.5% itself in 2032, our valuation would reach around close to about half a trillion. That is what is the estimated. Just a linear increase of 18% would take you in 2032, but we are expecting that it should go much higher. At least in by 2047, the government's expectation is that we should be a $3 trillion economy, and probably we are in the that right space, but there is a lot of challenges we need to actually inculcate in this. So basically, the contributions which come in this area is majorly coming from bio industries. That is the major contributor. But the next best is coming from the biopharma. And due to COVID, there were a lot of research which was happening, which is about 6%, and agro industry, which is bioagro. I will explain these concepts later. Bioagro is about 8%, and we have bio IT, which is basically all the IoTs and also AI and ML and everything in biology, is also contributing about 7% now, right now. So there is a large scope for all of these other smaller contributors to the economy to actually grow up and contribute big way. And I would like to, before I go further, I want to disclose that I'm actually talking for DBT. So some of the, most of the slide or some of the slides have been shared by my own colleague, Secretary DBT, who is Dr. Rajesh Gokhale. So I just wanted to make that disclaimer that I don't want to be telling that I am doing it everything myself. So this is basically Department of Biotechnology has actually been thinking about how to sustain this kind of Atmanirbhar Bharat in the case of biotechnology. So major vision which has been thought about in 2023-2024 by the DBT itself is to actually look at biopharmas. Whenever I am talking about biopharmas, we get confused that it is those chemicals we are talking about, synthetic chemicals. No, we are talking about making molecules from the biology, basically proteins or your cells, RBCs or blood itself and all of those things. You are actually using that to create drugs. And that is what I meant by biopharma. And when I say bioagri, it is not agriculture in the normal way, but actually in sync with the soil which you are having should be able to not get spoiled. It should be actually retaining all its qualities while you are doing the agriculture. So you have to maintain the eco-friendliness of the soil itself. So all the practices for that needs innovations. And that is what is bioagri. Of course, biotechnology industry is one another emphasis where newer technology is coming. Then bioenergy, which is one of the major important thing, because today we are talking about bioethanol. Similarly, many other energy innovations are actually coming up in the sphere from the biology side, and that is a big push because we are reaching a limit onto the other areas. So we want to actually complement it from the resources, regeneration from the resources available. Similarly, bioservices have to be improved. That actually COVID showed that we actually improved significantly, which needs to be increased. Similarly, we need to actually develop, and I'm sure what Sanjay is going to talk is going to be on biomedical technology, which is developed by India, and there is a large scope for that. Major emphasis is going to be on bio AI today, and there is a big push for it, and that is happening all over, and DBT is actually working towards that. One of the things which is missing in India was the biomanufacturing itself, and all of us know the need for such a thing is because we are actually undergoing many threats. One of them happens to be the climate change, Even today, actually today we had, so we actually mourned for the deaths of the people in the landslide. How do we identify them? You need to have those services available, and today RGCB is actually deploying their workforce there to actually identify all of the patients, people, victims, and to give it their bodies back to the rightful owner of that body. And that is something which is happening. So such services needs to be available at the will whenever the government wants or when the people want. Those kinds of services need to be there. So climate change, unsustainable material consumption, resource utilization and waste generation, all of them make us to think about developing bio manufacturing itself. What is the ways forward? Basically, we are looking at manufacturing that can use biological systems, and that's what I mentioned in the previous slide. So use microbes, cells, enzymes that are produced and produce them in commercial scale, and make it relevant products for doing these manufacturing. Similarly, you actually have to work on areas like food, which will be talked about by Dr. Anantharaman, and bioplastics, chemicals, and biofuels, etc. How do we do it? The basic thing is that we will be actually producing living factories. That means actually it is a living factory and machines, and engineering flexible designs, reclaiming resources from the waste, and effective utilization of in situ resources. These are the ways we are going to go forward. And DBT has actually come out with 6 different pillars in this direction. And this, I want to thank the government that this year's budget, they have actually given about 700 crores for this particular initiative. And that is means the government is also as interested in developing this kind of a thing. What are the things which we are actually looking at in DBT is bio-based chemicals and enzymes, which is what we need to actually have if you want to have ecologically friendly things. Then we are actually looking at functional food which is not actually killing animals, or we are actually not going to have this. So research like stem cell based meat production, which looks exactly, smells exactly like the meat you eat, so that you don't have to kill an animal to actually do this. Similarly, today's therapeutics is actually based on precision biotechnology, biotherapeutics, where each individual is considered not actually same treatment for everybody. So you need to actually develop those kinds of technologies where an individual is more important than the disease itself. And that, if you look at it, it comes from the Ayurveda also. People actually look at what happens to you, and that is what the allopathy is actually going through now. Similarly, climate resilient agriculture, that means drought conditions you should be able to actually have. One of the best examples I would actually quote is, if anybody wants to know, that Kutch actually was a desert, but today it is one of the best in exporting fruits from that place. That kind of resilient crops we need to actually grow to overcome the problems when a pandemic happens or any of those things happen. We should be able to supplement these kinds of technology. Similarly, one of the major issues everybody is talking about is carbon capture. Taking carbon dioxide and converting it to useful products is one of the things, and biology has the best, because of course you know that carbon dioxide gives you water and also oxygen from the plants. So similarly, some technologies can be brought about. And basically today we have very big blue economy, which is called marine, which is basically tomorrow we are having a belt right here in the sea around us and oceans around us, and that is where the research is going to be the end. Space, when you are taking people to the space, you need to do a lot of astrobiology and various other kinds of things. So these are the areas where we are going to work. But what is the problem we are facing today is basically we have been funding very sporadically, basically spray and pray. We hope that we just throw the money and somebody will come out with technology. That is not going to take us anywhere. And this is something we were discussing, Rajesh, and we are all discussing. We are actually caught in a middle income trap. Basically, we are in a high if you are looking at GDP, it is growing, but that doesn't mean the people will actually become, it will be a developed nation until unless all the people will actually have a better income. So the WHO has a rate that $13,200 if per person has per capita, then basically then you are a developed country. So many of us actually have a growth, but growth doesn't mean that you will actually be a developed country. So we need to actually look at that. So the way forward which is being proposed from the DBT side also is, do not actually spray and pray, but actually give focused funding and a larger money to a large group of people to work on a very thematic regions, and that's something we have actually started. So basically research return on investment has to be there whenever you are actually looking at, and basically world class facilities needs to be developed and skills complementing that should be there. I would stop at that, and I would say that these are the things we need to, challenges are there, and these are the things we have been thinking, and hopefully this direction if we take, we